Okay, today we're going to look at section 3.5, solving linear inequalities. So, solve linear inequalities, let's take a look at what we're really doing. So back in lesson 3.1, we learned to solve the equation 3x minus 1 equals 0, both graphically and algebraically. So today we're going to look at a little twist on this, and we're going to look at how to solve the inequality 3x minus 1 is less than or equal to 0, both graphically and algebraically, using the same technique we did in 3.1. Before we can do that, though, we need to talk about some notations and symbols. So we need to understand the inequality symbols, what they mean, and what you're going to use when we display our answers. For right now, since we're doing a one variable, the two inequalities, less than and greater than, when you see those symbols, that means that the boundary number, which we'll talk about in a little bit, is not included in your answer, and that we're going to use an open circle in our solution graph. And an open circle means that the point that it's boundary, that point is not part of the answers. Whereas if we have the less than or equal to symbol, or the greater than or equal to symbol, this means that the boundary number is included, and we use that as a dot in our solution graph. So let's look at an example. We're going to solve this one. All right, to solve this one graphically, okay, so unlike equations, inequalities have many solutions. There is not just one solution, there's an infinite number of solutions. So what we want to do is we want to find that boundary number. And the boundary number is the number that separates the solutions from the non-solutions. So that's what a boundary number does. To find the boundary number, we're actually going to solve this equation, because the solution to the equation will produce the boundary number. Okay, so we're going to use a graphing technique that we did in 3.1, and we're going to graph the left side as a line and the right side as a line. And that gives me the two lines, y equals 3x minus 1 and y equals 0. Okay, and we want to show where they intersect. So I'm going to go off to the side over here. I got my graph paper ready to go. We're going to graph y equals 3x minus 1 and y equals 0. And let's graph those two things on the same graph paper and see where they may intersect. So you can make a table for each one. The first one here is the y-axis. I'm sorry, the x-axis. The x-axis is the line y equals 0. Because this is where the y values are 0, so it's y equals 0. So there is one of our lines right there. So now we need to do the other line. You can use any technique that you want. If you wanted to make a table, which is how I showed you, then you just plug in some numbers, 0, and 1 above it, and 1 below it. If I plug in 0, I get -1. If I plug in 1, I get 3 minus 1, which is 2. And if I plug in -1, I'm going to get -4. You can also use the slope technique that we did before. So if I knew this first number right here, I can add 3 to get this point, and then subtract 3 to get that point. That's kind of what we do with using the slope concept. Once you have your points, you can put a dot on here. So we've got 0, -1. Now you can see right here, when we put a dot, we're indicating that that is a solution. So that's why we put dots for solutions. And we'll put an open circle if it's not. We have the point 1 and then 2, so we have one up here. And the other one I don't have, I don't go down far enough for that one, but I got 2 points here. I'm good to draw this out. So we line everything up nice and neat and pretty. Once you have it lined up, draw your line. This is y equals 3x minus 1, and this was y equals 0. And I can see that they're going to intersect right there. So that point right there, which we're going to name, as you can see, I have it here 1, 2, 3. So that is 1/3. I got 1/3, comma 0. That 1/3 is the boundary point. So x equals 1/3 is your boundary point. The boundary point. So what are we going to do with this? How does this help us out? Okay, let's go back to the inequality that we're trying to solve. We had 3x minus 1 was less than or equal to 0. So I want you to think of it this way. So for this inequality right here, it's asking, when is this line below that line? When is this line below that line? Well, this is when it's equal to this line, and below it, it's all these points down here. Since the line right here is below the y equals 0 from this point, and every point over here will produce a y value that will be below 0, then that is my solution. So from this picture, the solution to this equation right here, this inequality right here, is all the x's less than or equal to 1/3, because it's all of these x values that are less than 1/3. And so that's the solution to that inequality right there. So the question, when is this line below that line? Now, we're not, we don't always do a two-dimensional graphing. We like to display this in a one variable solution graph. So the one variable solution graph is just a number line, the x-axis literally. And where did the boundary point come from? The boundary point is right here at 1/3. And I just put it where I want, because I'm just going to, and then I want all the x's less than 1/3. So I'm just going to kind of mimic what I saw right here. So that's the boundary point. So we put a dot. And where's all the line below 0? Everything to the left of that. So that would be my solution. When you shade it that way, just like that, put an arrow in here, meaning we're going in both directions, all the way out there. So a dot here, shading that way, because that's where the solutions lie. Everything on this side are not solutions. Everything on this side of that point are solutions. So that's what the boundary point does. Separates the solutions from the non-solutions. So that's the graphical approach. Our goal is to get to this right here and to draw this graph right here through this concept. But we're not always going to be doing a graphing approach to things, so you need to be able to do the algebraic approach. So how do I do an algebraic approach? What am I doing here? To solve this inequality, 3x minus 1 is less than or equal to 0, algebraically, you're going to follow all the steps that are required for solving an equation. Solving the equation gives me the boundary points. So we're going to go through the process of solving this just like if there was no inequality, just as if there was an equal sign here, with the one special step that we need to remember. And here it is. I'm going to let it sit right here. You're going to follow all the steps for solving a linear equation, but if in the process of solving you multiply or divide both sides of the equation by a negative number, then you must change the direction of the inequality symbol. That's the one rule you need to keep in mind for inequalities. Otherwise, it's just as if they were an equation. If you multiply or divide both sides by a negative number, then you must change the direction of the inequality symbol. So with that in mind, let's look at this problem right here. If I can visually see an equal sign here, then the step I need to do is add the opposite of 1 to both sides. I get 3x. The symbol still points in the same direction. Then I'm going to multiply by the reciprocal or divide by 3, whichever way you're comfortable with. This side over here becomes an x. This side multiplied both sides by a number, but it is not a negative, so the inequality symbol still points in the same direction. And I get x is less than 1/3. And you can see that that is indeed confirming what we established up here, that x is indeed less than or equal to 1/3. And so once you have this, you can draw your solution graph if you didn't already do so. So these two usually go together in that fashion. Okay, let's look at another example. In this example over here, we're going to do this top one. Okay, we're going to do this top one up here. We're going to go through the graphical approach to it also. So we're going to look at it as y equals negative 4x minus 3 and y equals 0. And we're going to graph both of those on the same coordinate system. We can make a little table over here if you want. The whole point is to find 3 points. If I plug in 0 and then a 1 and then a negative 1, let's see what we get. Plugging in 0 gives me negative 3. Plugging in a 1 gives me negative 7. And plugging in a negative 1 gives me a positive 1. So let's go graph that out. Let's see what we can find this where this thing has the boundary point. So first off, here's our graph right here. And this axis right here is the y equals 0 line. And so then the other one we put in our dots, we got 0, negative 3. And then we have 1, negative 7, so I can get it in right here. And then at negative 1, I have positive 1, so there's my 3 dots. So we can draw this line. And so this line up here is y equals negative 4x minus 3. And we can see that it's going to be the boundary point right there. And so you can see kind of like the difficulty of why we don't do this process for finding, we do an algebraic approach. The graphical gives us an idea where the answer is, but I don't know exactly where that is. And I can speculate by looking at my numbers, but I still don't know exactly where that is. But for our purposes in here, we can still answer the question because I'm asking, when is this line bigger than this line? When is this line above that line? Here's the y equals 0. When is the line above this horizontal line? Well, from this point all the way over here is where all those points are higher than that. Okay? So once I find that value, then I'll know how this works. I can see that when is the line above this y equals 0? From this point and all the points over here. So what is that point? Well, let's go solve it algebraically. So we have negative 4x minus 3 greater than or equal to 0. Same process for linear, so we're going to add the opposite. Negative 4x is greater than or equal to 3. Either divide or multiply by the reciprocal. So if you're going to multiply by the reciprocal, it's going to be a negative 1/4. A negative 1/4. So x, now I have multiplied both sides by a negative number. So this symbol, which was pointing to the right, is now going to point to the left. And there you go. So that number right there was a negative 3/4, 0. And my solution is all the points to the left of that, because that's where the line is above 0. And it confirms right here. So all the x's that are to the left of a negative 3/4. The one variable solution graph, you just need to put negative 3/4. Because of that symbol, we're going to put a dot. And we're going to shade everything to the left. This is how you draw the solution graph. There's my algebraic solution. And then I can see that my graphical solution is going to be all of these points over here. Okay. Let's do another example. I have one right here. Let's go ahead and solve this one algebraically first and then confirm it with the graph. Let's do a little bit different this time. So algebraically, I'm going to add the opposite. Now I have 2x. I only subtracted. I did not multiply or divide, so the symbol still points in the same direction. Then I'm going to multiply both sides by 1/2, the reciprocal of 2. I am not multiplying by negative, so the symbol still points in the same direction. So x will be greater than 1. Now, according to my one variable solution graph, this is what it should look like. Here's the number 1. Because of that symbol, I have an open circle at 1 because 1 is not included. It is a boundary, but not included. And I want all the x's that are greater than 1, which means I'm going to be shading over here to the right. So this is what the one variable solution graph looks like. Let's go and confirm this graphically now. This time we're confirming graphically. Y equals 2x plus 5. Y equals 7. Okay, and what should happen when I graph these out is they should intersect at 1. And then when is this graph greater than 7? So this graph should be bigger than 7 from 1 and to the right. This is what we should be seeing. A couple of points for this graph. 0, 1, negative 1. And over here, add 2. And over here, we get 3. So I have the graph prepared right here. Let's start off with the horizontal y equals 7. So here is the y equals 7. And the other one we had a dot at 0, 5. And then we had one at 1 and 7. And then another one at negative 1 and 3. You can also, from this point right here, go the slope of 2, so that's up 2 and over 1. That's a rise over run approach. Up 2 over 1. So you can get another point that way. Line everything up. We draw this graph right here. And we can see this is the y equals 2x plus 5. And we can see that they're going to intersect at 1. So this is the point 1, 7. And when is this line greater than 7? From this point onward, this way. It's where this line is above over here. So from this point that way. So you can see we actually indeed confirmed our solution that we knew. So here I can say, because of the inequality, the boundary point is not included in my solution, but I can see that x then has to be greater than 1 from this graph, because that's when this graph is above that graph, when x is greater than 1. When x is 1, they're equal, but when I am bigger than 1, then this line is above the 7. So this is what we're going to be doing in 3.5 on your test and such. You're definitely going to be asked to solve an inequality algebraically and draw the one variable solution graph. And I will inform you if this kind of thing will be on there.